Let's just jump right in, because as of July 4th, 2026, the frontier AI landscape has fundamentally changed. xAI has officially deployed Grok 4.5 into private beta. But here's the kicker. They aren't releasing it to the public, and they aren't testing it in some sterile simulated lab environment. Instead, they've launched it straight into the live production workflows of SpaceX and Tesla. Today, we're sticking strictly to the verified facts to unpack exactly what happened, the new architecture behind it, and why this is a massive deal for enterprise AI. So the absolute most critical confirmed fact from this July 4th rollout is just the sheer scale of the new model. Based on xAI's core announcements, Grok 4.5 is running on a newly engineered foundation they're calling the V9 architecture, and it's sitting at a massive 1.5 trillion parameters. To put that into perspective, this effectively triples the size of their previous production models. But honestly, the real disruption here isn't just about the raw math or the scale. It's really about the type of data that's feeding this giant engine. See, what makes this deployment so unique is how it's actually being evaluated. Traditionally, frontier labs test their models on synthetic, multiple-choice academic benchmarks, things like MMLU or human eval, and then they claim victory. Well, xAI just entirely bypassed that old playbook. On July 4th, they deployed Grok 4.5 directly into the high-stress, active workflows of SpaceX and Tesla. They aren't checking to see if it can pass a standardized test. They are forcing it to solve real-world problems in environments where a failure has immediate, tangible, physical consequences. To really get the mechanics behind this deployment, we need to look at a major structural shift. Legacy xAI models, the ones powering your daily interactions on the X platform, well, those were optimized for parsing high-volume, low-latency text. They were fantastic for social media, but they lacked deep, multi-layered reasoning. The V9 architecture, on the other hand, represents a total ground-up overhaul. At 1.5 trillion parameters, it's explicitly built for complex logical reasoning and serious software troubleshooting. But here's the thing, if you feed a model of this size standard internet text, it hits a cognitive ceiling. It absolutely needs something way more complex to learn from. And that brings us to a very specific, verified number: $60 billion. Feeding an engine of this scale requires highly specialized logic data. According to the Build Fast with AI Frontier records, xAI secured this crucial data pipeline by acquiring Anysphere, the developers behind the incredibly popular Cursor IDE, for $60 billion. They didn't just want static code repositories, they wanted the actual dynamic history of how human developers think, type, and solve complex problems in real time. The V9 pipeline actually operates in 3 distinct steps. First up is IDE interaction harvesting, which means ingesting raw, anonymized developer sessions. Second, we have microstroke delta tracking. This is fascinating. The system actually tracks specific intermediate microstroke deletions to isolate a human developer's debugging rationale when they're diagnosing an application failure. It's essentially watching them think. And third, multi-file graph mapping. It maps these human corrections across complex multi-file dependencies. So it explicitly teaches the model how a change in a backend system impacts a totally distant front-end component. It's not just copying code, it is literally copying human cognitive troubleshooting. And the crazy part? We already have independent validation that this approach is working. According to the Developer Systems Feedback Forum from July 4th, early system evaluations by engineers like Mehul Mohan confirm that the V9 model handles complex, multi-file code dependencies with an accuracy that matches or even exceeds legacy frontier architectures. It is successfully replicating human cognitive processes right inside production-grade coding environments. So, with that logical core fully trained on developer behavior, xAI is now utilizing Elon Musk's industrial footprint for real-world application. Over at SpaceX, Grok 4.5 is embedded directly into aerospace engineering pipelines. We're talking hyper-complex material science calculations, fluid dynamics for Raptor engines, and incredibly intricate avionic codebases. The crucial takeaway here is this. If the model makes a logical error, it isn't just failing some text prompt. The failure is instantly caught and corrected by real-world physical equations. It's an immediate, uncompromised structural validation engine. At the exact same time this aggressive strategy is unfolding at Tesla, the V9 architecture is being forced to interpret massive multimodal data streams coming straight off live automated assembly lines. It's parsing autonomous vehicle edge cases encountered by millions of cars navigating actual physical roads. If Grok 4.5 can write a hyper-efficient vision parsing script that runs flawlessly on Tesla's low-power onboard hardware, well, it's proven its intelligence in the physical world, not just on some digital leaderboard. This continuous stream of operational data is supporting a massive strategic divergence from the rest of the industry. Historically, elite frontier labs rely on 500 billion to 1 trillion static parameter weights, they validate them on closed academic tests, and major platform updates drop maybe once a year. xAI has confirmed a totally different playbook. They are operating at a 1.5 trillion dynamic parameter scale, validating on live physical pipelines, and releasing entirely new scratch-trained variants every single month. The verified timeline maps this out incredibly clearly. Before 2026, the entire industry was locked into those annual lab drops. Then, July 4th, 2026 marked the Grok 4.5 private beta launch. And now, from August through December 2026, xAI has committed to strict, monthly scratch-trained iterations. For enterprise clients who need continuous performance gains, this is a massive shift in deployment velocity. You no longer have to wait 12 months for a delayed competitor update. You can tap into a hardened, physics-tested model engine that literally evolves every 30 days. These aggressive monthly iterations aren't just for show. They are explicitly serving as the foundation for the next massive leap in computational scale. Deep inside the Colossus compute complex, xAI has officially initiated training on their next-generation architecture, Grok 5. And the target scale, which was cited by Buildfast with AI, is absolutely staggering. We're talking 6 to 10 trillion parameters. But here's the catch. You cannot train a model of that size without an immense, high-quality data stream. And that is the true strategic value of Grok 4.5's current deployment. By running these continuous daily physical improvement loops on the factory floors of SpaceX and Tesla, xAI is actively gathering the high-density operational data required to train Grok 5. They are explicitly teaching this future AI how to interact with physical realities, write flawless system-level code, and manage the incredibly complex physical world. Which brings us to the core question leaving the tech industry reeling today. As xAI integrates real-world physics into strict 30-day monthly iterations, can legacy software labs, who are still relying on closed academic benchmarks and annual release cycles, possibly maintain their grip on the enterprise market? The laboratory era of AI appears to be shifting, and the real-world deployment war has officially begun. Thanks for joining me for this TrendGuards Explainer. We'll continue tracking these verified deployments to separate the facts from the hype, and we will see you next time.
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.